This is a series of video lectures that is going to cover the My Very Own pamphlet that I gave you out in class. So if you can open up to page 1, then we can see that your exam Tuesday, and you should have a 4-function calculator or scientific when you walk into the gym. Have a couple of pens and a couple of pencils. Today we're going to cover a couple of the topics, but before we get there, it is very important that you put an asterisk in this section of the page. You cannot prepare for the chemistry exam the night before. You have to study, you have to do problems, you have to review, and that's the purpose, one of the purposes of this pamphlet, is to do some review for the exam. Topic 1 is the atom. The modern view of the atom has evolved, and sometimes they ask how, and it was over a long period of time through the work of many scientists. One of them was Dalton. He discovered that elements are made of atoms. So gold is composed of gold atoms. Atoms of an element are the same, so all gold is composed of all gold atoms. Compounds are formed from the combination of atoms. In the Rutherford experiment, that's the one where they bombarded gold foil with alpha particles. It showed that most of an atom is empty space with a small, dense, positive charged nucleus. The Bohr model is the one with circular orbits. In the wave mechanical model, we have to know that orbitals are areas where electrons are most likely to be found. So at the bottom, we're going to write in that sodium is composed of sodium atoms, but sodium and chlorine combine to form NaCl. Aluminum, if we draw the Bohr model, it has 13 protons. It has 2 electrons in the first shell. It has 8 electrons in the second shell. And it has 3 electrons in the outer shell. The electron configuration is 2-8-3. It has 3 valence electrons, and when we do it, 2 on top, and then 1 on the side. So if we turn to page 3, each atom is made of a positively charged nucleus, we should know that, where the electrons orbit around and are negatively charged. Protons and neutrons are found in the nucleus. Protons have a positive charge, neutrons no charge, and electrons have a negative charge. So all of that we should know already. If we are an atom, protons equal electrons. The mass of a proton is about 1 AMU, a neutron is 1 AMU, and an electron is 0. Electrons absorb energy and move to a farther out shell. When they're in the lowest level, they're called the ground state. When it absorbs energy and moves farther out, it is called the excited state. When the electron returns to the lower energy level, it gives off the energy and in the form of light. So if we have aluminum 27 with an atomic number of 13, it has 13 protons, 14 neutrons, the difference between the two, and 13 electrons. But if we look at aluminum 27, but it is the ion, it will still have 13 protons, it will have 14 neutrons, but this time it will only have 10 electrons because it lost 3. The top number is the mass number, and the bottom number is the atomic number. So the ground state for aluminum is 283. In the excited state, we don't change the number of electrons. We just move one to a farther out shell. And it doesn't have to be an outer electron either. When the electron returns to the lower energy state, it gives off the energy it absorbed as light, which we see as a bright line spectrum, which is used to identify the element. If we go to page 4, we're still on topic 1, the atom. The outermost electrons are the valence electrons. These affect the chemical properties. And we should know how to do Lewis structures for the different atoms. We did 11 before. Same elements, same number of protons. Isotopes are atoms with equal number of protons, but a different number of neutrons. And we should know how to calculate an average atomic mass. So in the space below, the Lewis dot diagram for nitrogen. It's in group 15. It has 5 valence electrons, 2 on top, and then 1 on each side. So its electron configuration is 2-5, and it has 5 valence electrons. Carbon 12 and carbon 14 are isotopes of each other. And atomic mass is calculated on the percent abundance and changing it to a decimal, multiplying by its mass, the mass of the isotope, plus the percent abundance of a second isotope, written as a decimal, times its mass, plus, and then we have to do it for however many isotopes there are. Page 5. We're just going to do the second topic. Topic 2, nuclear chemistry. Remember, it's the ratio of protons to neutrons that determines stability. Table N is used to write equations and determine how the decay occurs and what its half-life is. Transmutation is the changing of a nucleus into a new nucleus. Spontaneous decay releases particles from the nucleus. We have 4 different types of nuclear reactions, and we can write these reactions with equations. And we definitely have to know that the energy from a nuclear reactor converts mass into energy. So carbon 14 decays by beta decay. And don't forget, it's a -1. So the bottom number will be 7 of the new particle. The atomic number is 14. We looked it up. That's nitrogen. This is natural transmutation. It is also beta decay. The nitrogen-14 can be hit by an alpha particle, causing it to turn into oxygen-8 and also giving off a proton. Since there is a particle from table O to the left of the arrow, this is artificial transmutation. If we take uranium-235, atomic number 92, and we hit it with a neutron, it will turn into krypton 92, atomic number 36, plus barium-141, atomic number 56. And the identifying feature is that it gives off more neutrons. This is fission. And then if we take two light particles and combine them, fuse them together, this is fusion. And finally, on page 6, the energy released from a nuclear reaction is much greater than a chemical reaction. There is risks with nuclear energy, and radioactive isotopes can be used for multiple purposes. So cobalt-60 is used in cancer treatment. And iodine-131 is used in the treatment of thyroid disorders. And I think that's going to be it for this lecture. So we got through 2 of the units. So we'll see you later.